In this section, we're going to continue our conversation regarding Chapter 17 in residential and commercial absorption systems. Remember, with residential absorption system air conditioners, the ammonia becomes a vapor, flows through the leveling chamber and rectifier to the condenser as a high temperature, high pressure gas. The outside air passes over the condenser and removes the heat from the ammonia. The ammonia condenses and passes through the condenser restrictor back to the pre-cooler. What we have in this picture is a chilled water residential air conditioning system. Again, you'll notice that we still have all of the same parts. We have the leveling chamber, we have a rectifier, we have solutions, we have a chilled water system that absorbs the heat from the condenser and allows it to be cooled. The pre-cooler acts as a heat exchanger, reducing the temperature of the liquid ammonia before it reaches the evaporator. It also heats the cold ammonia vapor, leaving the evaporator. Pressure drops as the liquid ammonia, leaving the pre-cooler, passes through a restrictor into the evaporator. Here the liquid ammonia picks up heat from the chilled water circuit and boils. Ammonia vapor passes through the pre-cooler to the absorber heat exchanger. In the generator, most of the ammonia builds up, leaving a weak solution. The solution leaves the generator at high pressure. It passes through the restrictors that meter the flows, separating the high and low pressure sides of the system. Resistors in the line leading to the absorber heat exchanger and lower the temperature of the solution by increasing the heat transfer. At the absorber end, heat is removed by outside air, and the process of ammonia absorption is complete. The solution moves from the absorber through the condenser to the solution pump. The pump forces the solution at high pressure to the rectifier. The solution picks up heat from the surrounding ammonia vapor. Along the way, the preheated solution returns to the generator. The cycle begins all over. The absorption cycle used for small air conditioning system is a little bit different. A weak solution returns to the generator by the solution pump. The burner heats the solution and drives off the vapor. The vapor flows through a generator assembly, coming in direct contact with the weak solution entering the generator. During the process, the vapor is partially purified. This is the diagram of the small air conditioning system absorption cycle. You have a generator, we have a valve, we have the rectifiers. We have an absorber, and then we also have our water pump down at the bottom, chilled water in and out. A rectifier contains rings that have large surface areas. As ammonia vapor passes through, it comes into direct contact with the rings. The rings help remove any water vapor left in the ammonia vapor. Purified ammonia vapor flows in the condenser tube. It is cooled by the air moving across the condenser. Hot ammonia vapor in the condenser gives up heat to the air and becomes liquefied. Liquid refrigerant leaves the condenser and passes through the first restrictor where pressure temperature drop. It then flows through the outer tube of the liquid suction heat exchanger. Heat is given up by the cooler ammonia vapor in the inner tube. Cooler ammonia vapor is flowing through the inner tube in the opposite direction. From the liquid suction heat exchanger, liquid ammonia enters the second restrictor. Pressure on the temperature are further reduced. Low pressure, low temperature liquid refrigerant flows through the chiller coil, which is the evaporator. A glycol and water solution cascade down the evaporator. It gives up heat and vaporizes the liquid refrigerant. Refrigerant vapor leaves the chiller and passes through the inner tube of the liquid suction heat exchanger. It picks up heat from the liquid refrigerant flowing through the outer tube in the opposite direction. Vapor enters the absorber header and completes the refrigeration cycle. The hot, strong solution left behind as ammonia vapor is driven out of the weak solution in the generator. The solution passes through the coil in the generator. The solution leaves the generator and enters the inner coil of the rectifier. The strong solution comes into thermal contact with the weak solution. As the strong solution leaves the rectifier, it passes through the strong solution restrictor. The rectifier reduces the solution from high side to low side pressures. The strong solution leaves the restrictor and enters the absorber header. The inner tube contains a strong solution. The outer tube contains ammonia vapor. The strong solution tube has two small holes. These allow the strong solution to flow out into the direct contact with the surrounding ammonia vapor. They combine to form a weak solution. The strong solution and ammonia vapor leave the absorber header and begin to flow into the absorber. This strong solution completely absorbs the vapor, forming a weak solution. The weak solution leaves the absorber and is picked up by the solution pump, which moves the solution back to high pressure side of the unit. As the solution passes through the rectifier, heat is picked up from the strong solution vapor flowing in the opposite direction. Preheating the weak solution as it flows through the rectifier reduces the heat input required, thus the efficiency of the cycle is increased. The weak solution leaves the rectifier and drips back into the generator analyzer to begin another cycle. When you install residential absorption systems and when you construct them, the supply and connections are covered with flexible hose. The hose is secured with stainless steel clamps. The coil is located on the air conditioning gas furnace. Copper tube piping should be used if the coil must be located in the hot air stream of the furnace. The condensated drain line must be insulated. All piping must comply with codes. The control transformer provides power for the control circuit. The circuit includes a gas valve, direct spark igniter, and a time delay switch for both heating and cooling. This is an example of an install of the single unit absorption system with a gas furnace. You'll notice the chilled water lines going to the outside and the A coil on the inside. An electromagnetic ignition system provides direct spark ignition of the main burner with a 10-second flame detection system. A solid-state time delay prevents continuous circulation with both the refrigeration solution and chilled water. Many safety controls are included, including flame detectors, chilled water switches, heating side operation controls. We have to remember that the capacity of air-cooled chillers varies with the ambient air temperatures and the temperatures of the chilled water leaving the unit. Self-contained units with insulated evaporator coils, glycol, and water solutions. The solutions circulate through a heat exchange coil on the furnace bonnet. They may be used in separate air circulation systems within a building. The absorption system can be utilized as multiple unit load systems. They're often used in large office buildings, strip malls, etc. Internal temperature sensing devices monitor return water temperatures. Temperatures higher than normal indicated an increased need for cooling. Zone valves can also be used for control. The low pressure and temperature of a chilled water system allows the use of PVC. Units range from 3 to 25 tons. Most units are serviceable and equipped with service valve. Training by manufacturers recommended prior to servicing units. You have to be aware ammonia is toxic and flammable when mixed with certain ratios of air. Wear a face shield and safety goggles. Ammonia reacts with some metals. Use only steel or aluminum tubing, gauges and fittings, and manifolds. This is an example of a system equipped with 4 service valves. The valves are on the high pressure and low pressure sides of the unit. The system is charged with a solution of ammonia and distilled water, with a pH of 6.0, and a corrosion inhibitor. A solution cylinder is used to charge the system, contains about 35 pounds of distilled water, 15 pounds of anhydrous ammonia, and an inhibitor. If a white participant forms while making the solution, discard it and make a new batch. Anhydrous ammonia is available in 25-pound cylinders. The cylinder has both a vapor and a liquid valve. Note the charging line connects to the liquid valve of the anhydrous ammonia cylinder. A pail partially filled with water is connected to the vapor valve of the solution cylinder. Vapor is purged from the solution cylinder if necessary to lower pressure. The water in the pail will absorb small amounts of ammonia purged. The system must have correct pressures and amount of anhydrous ammonia. They must also have the correct amount of distilled water and inhibitor. Check the pressures by installing a 100% steel constructed gauge manifold, steel lines, and steel fittings. Do not use copper or brass. When you are using the 4 service valve, valve A checks the absorption pressure, purges ammonia vapor, adds ammonia liquid or vapor, adds solution, and it reduces the system pressure to atmospheric pressure. Valve C you use to check the high side pressure, checks the solution level, removes excessive solution, adds solution after repairs, and reduces system pressure to atmospheric. Valve D you use to purge air. You can add air, add solution, and remove solution. Valve E removes large amounts of solution. It determines if discharge chamber has proper amount of non-condensables. Commercial absorption systems are also used. They're used for air conditioning and heating systems. Some units use an ammonia, water, hydrogen continuous cycle. Others use water as the refrigerant and various chemicals as the absorber. This is an example of using water as a refrigerant and liquid bromide as the absorber. Notice we don't have any ammonia in this because of safety reasons. You can also use steam heat applied to the generator, percolates water vapor in a weak solution up to the separator. The liquid lithium bromide flows by gravity through the heat exchanger. It flows to the absorber where it absorbs evaporated water. A strong solution settles at the bottom of the absorber. It returns to the generator after passing through the heat exchanger. The pressure difference is maintained by a pressure head of lithium bromide liquid. Water vapor in the separator rises to the condenser where it's condensed. Water flows by gravity into the evaporator. It evaporates at low temperature due to its near perfect vacuum in the system. Water vapor is absorbed by the lithium bromide. Condenser water is taken to the cooling tower where it is cooled and used over again. Condensing pressure is about 50 to 60 millimeters mercury. Evaporator pressure is about 8 to 10 millimeters mercury. Lithium chloride is often used as a corrosion inhibitor. Using absorption units for air conditioning and heating is becoming more popular. It has advantages in solar applications. It can also be used to produce chilled water or to heat. When we have a process for cooling, refrigerant is dispersed into the evaporator and extracts heat from the chilled water. Refrigerant is vaporized, chilled water passes through the system. For heating, the evaporator functions as the condenser. Hot water in the evaporator tubes absorbs heat given off during condensation of the refrigerant. Heated water is circulated throughout the system. Heat for the system can be supplied using exhaust gas from another industrial or residential system, resulting in a large efficiency gain. When you service absorption refrigerants, the technician must be trained by the manufacturer. When servicing gas-fired absorption refrigerators, check for correct pressure using a water-filled manometer. The safety valve body has a manometer connection. Check the amount of gas fed to the unit by checking flame size. Flue has to be kept good and clean for good heat transfer. Fins on the ammonia condenser must be cleaned periodically. If the unit is too cold, check the temperature control dial setting. Take a time temperature graph of the evaporator. The most common complaint for a service call is little or no refrigerant. Check for an overloaded cabinet. Check for improper condensing temperatures. Check for little or no heat leaving a generation unit. Check for a restricted or shut off gas supply. And check for a restricted or dirty gas flue. The flue may be restricted if the unit is too close to the wall. Soot deposits cause problems as well. They need to be removed every month or two. Use a absorber, wipe, brush, or vacuum to do this. If the unit is not used, it may not freeze. Confirm that the burner is lit. If the burner is lit, blockage is most likely within the unit. After 10 minutes of operation, tilt the unit for 30 seconds to each side 3 or 4 times. If the unit does not cool, replace the cooling unit. If the system is overheated, the pipe to the condenser will overheat and the percolation pump will stop. Shut off the heat and allow system to cool. Turn the unit upside down several times to move the fluid. Restart the unit with a lower heat input to the boiler. If there's a leak, a yellow deposit will collect at the point of leak. This is different from a standard refrigeration system where we have a oil deposit that's at the point of leak. If the leak occurs in the evaporator, an ammonia odor will be noticeable. A burning sulfur candle will produce white smoke at an ammonia leak. When you service a lithium bromide system, it's a little bit different. Lithium bromide, which is a type of salt, is non-toxic, non-flammable, and chemically stable. When the lithium bromide is used in an absorption system, the water is used as the refrigerant mixed with the lithium bromide. It can be handled in open containers. It does become corrosive when it's exposed to air. It can irritate skin, eyes, and mucous membranes. The solution cannot be allowed to reach high concentrations or low temperatures as it will crystallize. Typical charge is adding lithium bromide solution to 120 gallons, 1 pint of inhibitor, 35 gallons of water, and 1 gallon of ethyl alcohol. The solution becomes thicker as the amount of lithium bromide increases, causing greater temperature difference between the refrigerator temperature and the chilled water temperature. If the solution concentrate gets too high, the refrigerant turns to a solid and must be dissolved. If the absorber becomes too cold, the solidification may occur. A strong concentrated solution means strong in its ability to absorb. A weak dilute solution means weak in its ability to absorb. The system is charged with R13 vapor to test for leaks. An electronic leak detector can be used. The system is Evacuated completely, evacuation is required to be able to reach 40 degrees and remove non-condensables. Evacuation is needed if the system pressure is 1 inch of mercury or more. Pressure is determined by a manometer connected by means of the service valve. When you're dealing with absorption systems, any one of them, you have to be aware of several safety issues. Ammonia is the most commonly used refrigerant. Odor is pungent and restricts breathing. It's toxic and can burn the skin and eyes. You need to avoid puncturing the system or creating too high of pressure to the system. You never want to cut or drill into absorption refrigeration mechanism. High pressure ammonia solutions are dangerous and may cause blindness. Many absorption units are heated with LP or natural gas. Gas piping must be leak-proof. Use soap suds to check for leaks. Never use an open flame around an absorption system or leak checking. Clean the burner flues periodically. Check the flame safety device by smothering the flame and noticing if the valve closes. The condenser duct system and condenser should be cleaned at least every 6 months. Use precaution when handling circuits. A circuit may become ground into the cabinet frame or part of the mechanism, resulting in a shock hazard. Ground the refrigerator to eliminate the danger. Couple terms you need to know about absorption. It's the adhesion of the thin layer molecules to a gas or solid object. Continuous absorption, continuous flow of energy input. Fuse plug, a plug or fitting made with a metal of low melting temperatures. It's a safety device. Generator, in an absorption system, it's the component in which the ammonia and water mixture is heated.